Hello students, now we are going to see encoders from module 3. Encoders, we have studied decoders. Encoders are performing the opposite function of decoders. Okay, that means it converts an active input signal into a coded output signal. Okay, the main use of encoder is to reduce the number of bits needed to represent the given information. And these encoders, in encoders we have 2 power n, that we can say 2 power n inputs and n outputs, and we have this enable inputs to activate the encoder. Okay, so mainly data inputs, which is nothing but 2 power n data inputs and n data outputs. So we are going to see some different types of encoders. First one is 4 to 2 binary encoder. 4 to 2 binary encoder. So 4 inputs, data inputs, and 2 outputs. Okay, so that 2 outputs are going to give binary coded form of inputs. So the block diagram, 4 inputs are taken as Y0, W0, W1, W2, W3. The outputs are Y0 and Y1. True table. These are inputs, these are outputs. Okay. So if W0 is the input, if W0 is selected by the selection inputs, W0 is selected, then the outputs will give the binary form of 0, which is nothing but 0 and 0. So if W0 is selected, here W0 is 1, so it is selected, means it is selected. So outputs are 0 and 0. Now if W2 is selected, then the output lines are giving the binary coded form of 2, which is nothing but 1 0. You can see W2 is selected here, so 1 0. W3 is selected here, so output is 1 and 1, which is nothing but 3. This is nothing but 3. Okay, so this is 4 to 2 binary encoder. Now the circuit diagram of 4 to binary encoder. 4 to 2 binary encoder. Okay, 4 inputs and 2 outputs. So for 2 outputs we have to take 2 OR gates. First OR gate is for Y0, second OR gate is for Y1. So Y0 inputs are W2 and W3. Sorry, Y1 inputs are W2 and W3. So W2 and W3 are the inputs of Y1 OR gate. Now Y0 OR gate. Y0 OR gates are Y1, W1 and W3. So for the Y0 OR gate, W1 and W3 are the inputs. So this is the circuit for 4 to 2 binary encoder. Okay. Now 8 to 3 encoder, 8 to 3 priority encoder. So block diagram will be 8 inputs and 3 outputs. 8 inputs, 3 outputs. Okay. Y0 to Y7. It's taken Y0 to Y7 and outputs are A, B, C. Okay, this is priority encoder. So what is priority? Why we need this priority? We'll see here. See, if everything is 0, then output is also 0. Output is also 0. Now Y0 is selected. Y0 is selected. So output will be the binary coded form of 0. That is nothing but 0 0 0. ABC are 0 0 0. Now Y1 is selected. So output is 0 0 1. Y2 is selected, so output is binary form of 2, that is nothing but 0 1 0. You can check this. Y5 is 1. Y5 is 1 means you have to get 1 0 1, that is binary form of 5. 1 0 1 we got. Okay. Now last one, Y7 is 1, so you have to get 1 1 1. This is the binary form of 7. Okay. Now we should know what is this X, why it is marked everywhere, it is marked X X X. Okay. Why this is X means this is priority encoder. Priority, what is priority encoder? Means if there is single one, if you take this, there is only one here, so that corresponding Y will be activated. That corresponding Y means Y0 is here, that will be activated, so that binary form will be produced by output lines ABC. Okay. For example, if two output lines are enabled, that time based on the priority it will produce the output. So which priority? So priority goes to higher input line. For example, if y0 and y1 are 1 1, y0 and y1 are 1 1, priority goes to y1. Priority goes to y1. Okay, so only 0 is marked as x, because if x 0 may, let it be, x means don't care, no, it may be 0 or 1. Okay, let it be 0 or 1, we no need to worry about that, because 0 is having less priority than 1. Okay, next we will see this. y3 is having 1. So previous values 0 1 2, let these can be 0 or 1, we no need to worry about that, because y3 is having higher priority. So till the y3 everything can be marked as x. Next we will take this one, y7 is 1. Okay, so y7 is having higher priority, so previous values can be 0 or 1, we no need to worry about that. So this is why we are marking x. Okay, so those who are having less priority, that are marked by x. So that is written here. Now decimal to BCD encoder, decimal values are from 0 to 9. So inputs are 0 to 9, so totally 10. Outputs are BCD output, binary coded decimal value we will get. You can check the truth table. So if the input is 0, we will get BCD is 0 0 0 0. If the input is 3, then the output is 0 0 1 1. If the input is 7, then the output is 0 1 1 1. If the input is 9, then the output is 1 0 0 1. That we can check. Input is 0, that is selected, 0 is selected, so outputs are 0. Now 3, to select 3 you have to put 1 in D3. D3 should be selected, so you will get 0 0 1 1. Next 7, for that D7 should be selected. In D7 you have to mark 1, so that time you will get 0 1 1. To select 9, 9 should be 1, so you will get 1 0 0 1. Okay, now we are writing the now we are going to make the circuit diagram. For before that, equations. So y3 is y3 is having only two ones. The two ones are, this is d8, this is d9. So y3 is equal to d8 plus d9, y2 is, this is d4, this is d5, d6, d7. So y2 is 4 5 6 7. Okay, 4 5 6 7. y1, this is d2, this is d3, this is d6, this is d7. So 2 3 6 7. Okay, now y0 is 1 d3 d5 d7 d9, d1 d2 d5 d7 d9. Circuit. So there are 4 functions, 4 AND gates you have to use, y0, y1, y2, y3. So y3 is d8 and d9. So all the inputs you are connecting with that particular OR gates. y3 is 8 and 9. y2 is 4 5 6 7. You are connecting with y2. With y1 2 3 6 7. You are connecting. Then with y0 1 3 5 7 and 9. So this is the circuit diagram of decimal to BCD encoder. Okay, thank you.